Hi friends, good morning. Welcome to my channel. So today we discuss about the compounding interest. So in our previous sessions, there are different concepts of simple interest. So let us discuss today on compound interest and how the compound interest will be calculated. So here there are different things. Here one is uh, annually, so half yearly, quarterly. Okay, these are the three different things. For example, if I say annually, so A is equal to P 1 plus R by 100 power N. Okay, so here A is equal to amount, P is equal to principal, R is equal to rate of interest, N is equal to years. So this is the notation here. So here one by one we will discuss. For example, if it is half yearly, what comes here is R by 2 divided by 100 to N. If it is quarterly, 1 plus R divided by 4n, like this. So we have a formula for the compounding interest for the three different time periods: annually, half yearly and quarterly. For example, uh, compounding interest for the fractions 3, 2 by 5 years. In this case, how we are going to write? P 1 plus R by 100 time is 3, then which is multiplied with 1 plus 2 by 5 R by 100. So this is another notation for the fractions. Then the next one will be present value of money, present value of X due in n years. So this comes under the time value of money. So now present value is equal to X divided by 1 plus R by 100 power n. Okay. So present value of X is how much? So this is time, this is rate of interest. It means after 5 years, if the rate of interest is 5%, what is the present value of 5,000 after 5 years? Like that. So after 5 years, the amount is 5,000. It means what is the present value of that 5,000 if it was added interest is 5%. So such type of notations, if it is asked, we are going to write a formula for this, and based on this formula we are going to get the solutions. So now what we will do is we are going to take some examples of the compounding interest. So very simple examples we will take. So compounding interest on 7,500, rate of interest R is 4% per annum and time is 2 years. Okay, what is required for the compounding interest is, one is principal, that is given 7,500, R is 4%, N is equal to 2. So amount is equal to 7,500, 1 plus R, that is 4 divided by 100 whole square, then 7,500, 104 divided by 100 square. How much it comes here? This is 50. So how we are going to write it here is in the notation of 104 divided by 100. So 26 by 25 whole square, and if we calculate, it comes around 8112. So this is the value. So 8112. Now what we are going to do is, our amount is 7,500. So 8112 minus 7,500, which is equal to 60112, right? So 500 it comes, 500 plus 100, so 6112. So this will be the compounding interest for a particular period of time. So this is one of the examples. So like that, we will take another example. So how we are going to solve the compounding interest for a different time beings. This is only for the first year, right? So it is a easy example for a only a particular year is given. It is not compounded annually or compounded half yearly. It is not given. So let us take another example of compounding interest, and from that we will try to go for some more a little complex example. Okay, that is find compounding interest on 8,000. Okay, that is 5% per annum interest rate, 5% per annum for the 2 years 4 months. I am writing in the shortcut form of the examples. Okay, compounding interest. So find compounding interest on 8,000 rupees at 15% interest rate per annum. Okay, 15% interest rate per annum for 2 years and 4 months and compounded annually. So this is also one of the important criteria. It is given annually or it is half yearly. For annually, the formula is different. Then generally time we will take time is equal to how much? 2 year 4 months means 4 divided by 12, then 2 1 by 3rd months. Okay, so let us say amount is equal to, what is the principal? 8,000, then 1 plus. So now rate of interest is 15. Okay, rate of interest is 15. So 15 divided by 100 whole square. Okay, then we have a different time period. Time is in the fraction, right? For this example is different. So now what we are going to do is 1 plus 15 divided by 100 whole square, then into here 1 plus remaining is 1 by 3, right? 1 by 3 multiplied with r, that is rate of interest, divided by 100. So like this. So this is the notation. So now we are going to solve this. So 8,000, what comes here is, this is 115, 115 by 100, that I am writing as a 23 by 20 whole square. This is one thing. Then this I am writing as a 3 5 ja. Then 100 plus 5, 105 divided by 100, and this can be 21 by 20. So it can be written as 23 by 20, 23 whole square and 2 times, right? 23 by 20, 23 by 20, 2 times, then 21 by 20. So 21 divided by 20. So all these things can be subtracted. Then this can perform, you can do multiplication, you can remove these zeros, and the remaining can be 11109. So now compounding interest is equal to, so what is the amount? 11109 minus 8,000, which is equal to 3,109, like this. So here even in the fractions, compounding interest we have identified in a simple method. Okay, so this is one example. Then in the next example we are going to take the compounding interest for half yearly. For example, compounding interest we need to find on 10,000, that is on 10,000 rupees in 2 years at 4% per annum, and interest is compounded semi-annually. Okay, semi-annually means I can say half yearly, don't get confused, half yearly. So I can write it as a half yearly. So in this notation, how we are going to solve? So let us say what is given is amount we need to find is equal to 10,000, then 1 plus rate of interest is 4%, but it is half yearly. So 4 divided by 2, that is 2 divided by 100, and it is half yearly. 2 times 2, that is 4. Okay, so this is the notation. Then 10,000, then 100 plus 2, 102 divided by 100, which is all power 4, 10,000. So this is 2 times 50, 2 times 51, so 51 by 50, 51 by 50. So you have to write like this. Okay, so now you can easily try to solve this. And how much it comes? Around 10,824 point some fraction it comes. Okay, so what is the amount? 10,824.32 minus 10,000. So it comes around 824.32. So like this. So this is also an example of the easy method of compounding interest, and this is for the semi annually or half yearly, we can say. So the next one is we can take quarterly. Okay, so next example, half yearly, annually we have seen, then fraction of years we have seen, semi annually we have seen. So the next one can be quarterly. Okay, so compounding interest on 16,000 we need to find at 20% per annum. Okay, 20% per annum for 9 months. So compounded quarterly. Compounded quarterly. So how we are going to solve this one? So what is given here? Principal is how much? 16,000. Rate of interest is 20% is given. Okay, 20% is per annum, so which is equal to 20 divided by 4, 5% per quarter. Okay, 5% per quarter. Then time is equal to 9 months. 9 months means 3 quarters, right? 3 quarters. So quarters, 4 quarters per year. So 9 months means we will get 3 quarters. So now what we are going to do is amount is equal to principal, that is 16,000, multiplied with 1 plus. Now the next is the rate of interest 5. This is 5 divided by 100 time, that is 3, right? So why we are not taken 9? Because for the 3 quarterly, compounding is based on quarterly. Why we have not taken 20? Because interest is also quarterly. Quarterly it is 5%. So that is the reason. So we are going to solve this in an easy way, right? 16,105 divided by 100 power 3. So how much it comes here? So I can say 25 times 520, then 521 times. So 16,000 multiplied with 2120, 2120 and 2120. So how much this will be? Around 18,522. So 18,522 minus 16,000. So this will be 2522. Like this we require to identify. Okay, so this is also one of the example. So like this we are going to solve the problems. So this is one of the example. So next also we can take one more example for the same type of notations. That is, if a particular sum is given in a particular time period, okay, what will be the rate of interest? If it is a compounding interest, we need to find out the rate of interest of particular time period. I'll take with an example. For example, if we have an amount 500 becomes 583 in 2 years, okay, what is the rate of interest? That is, what is R? If 500 is 583 in 2 years, okay, what is rate of interest? So how we are going to calculate? For example, we have amount that is 583, 500, 1 plus R by 100 whole square. So this is 583.2. So now how we are going to write it here is 583.2 divided by 500 is equal to 1 plus R by 100 whole square. So this is one notation. So I am going to remove this by adding 0. 5832 divided by, I am adding the 0 in the fraction, which is equal to 1 plus R by 100, okay, whole square. So to remove this, I am just doubling this. It will 11664 divided by 10,000. Okay, in order to remove this, I am doubling this 1 plus R by 100. For example, the value of this one comes around, if I calculate this one, it is around 108 divided by 100, which is equal to 1 plus R by 100. It means, see, this can be written as in this notation, that is 1 plus 8 divided by 100, right? 100 plus 8, 108 divided by 100. So 8 is what? Rate of interest. So rate of interest is given as 100. So like that we can solve some of the examples. So these are all simple notations that we are going to find it based on the simple formula that we have studied as part of the compounding interest. So compounding interest and simple interest. So both simple interest and compounding interest, based on exams we will get some of the bits from this. Mainly annual compounding interest, half yearly compounding interest, as well as quarterly compounding interest. And we have already seen in the previous classes simple interest based on some of the examples. And we require a thorough practice of all these sessions, because these questions are asked in SSC exam, bank PO exam, and different RRB exam, and all the competitive exams. So it looks very simple, but when we try to practice it, it will be very good. So thank you all for watching this video. Please, for other videos, please stay tuned with my channel. Thank you.